Yeah, welcome back again. So this time we are looking at another parametric test called two-way repeated measures ANOVA. The last class we have one-way repeated measure, it's ANOVA. So this time around, we want to look at two-way repeated measure ANOVA. And we must understand that one was looking at more than two dependent groups or samples, right? This time around, we are looking at more than two dependent group of sample in two categories this time around. Just look at it in the form of a two-way ANOVA, all right? Two-way ANOVA, but this time around in repeated measure now, okay? So the kind of categories you have there was two categories, okay? The same thing here, two categories also here, all right? Uh, we have more than two dependent groups, all right? So this time around, we in the one way ANOVA repeated measure we did, we have more than two dependent groups, all right, or samples, all right. So maybe you have a sample time. You want to use time, okay? You have T1, T2, T3. That is three, so which already more than two. But we only have time. Don't forget, only time. But this time around, we have more than that time is only one categorical variable. All right, so now we are having two categorical variable in this section now. Maybe you have time, you have other thing beside it. So to make it two categories, so that is what I'm talking about now. So you have to understand that in your data set, when you have such a column, you should know how to address it. Now, the way we have explained one way another repeated measure is same here. Like the difference is data and analysis, all right? So I won't go into too much details like I did for one way ANOVA here. So if you have not listened to one way ANOVA class, please you can do a repeated measure. You can go and do that so you can have clear understanding. I give several examples there of what we are talking about. So the repeated measure ANOVA are generally used for analyzing data where the same subject are measured more than once. Okay, more than once. But that is just repeated measure ANOVAs. Okay, I could have said more than twice, right? More than twice would have been better because if you for more than once, you can just use pair t-test. Period. That means that is twice. Okay, so I can correct myself here now more than twice. Okay, so I can correct myself now because if I say more than once, it means a PLT test fall into the category which is not supposed to be like that. So when we are dealing with more than twice, it means we are dealing with a repeated measure. So, but for twice, the PLT test is sufficient to handle that. Okay, so now this test also referred to as a within subject ANOVA or ANOVA with repeated measures. So the within subject terms means the same individuals are measured on the same outcome variable under these different time points or conditions. No, don't forget, I said the other time, I repeated again that when you didn't ANOVA, I mean repeated measure, that you are dealing with extension of PLT test, and it's always time dependent or time based. All right. Yes, there are always a period between one measure to another measure, and like that. Always period based. So take note of that. And the two-way repeated measure ANOVA is used to evaluate simultaneously the effect of two within factors. Okay, two within factors on a continuous outcome variable. Now, in the case of a one-way ANOVA, we have one within factors. All right, one within factors. So here we're having two now. Okay, this within factors now. All right, that is our categorical variable. It's become our within factors. So we're having them in two ways now on one continuous outcome variable, which is our numeric variable that we are looking at to measure. All right. So that is what we're talking about. How the effect they have on that continuous variable that we're looking at now. Last time we have a score for time. So here we are having different. Could be different thing. I gave different examples. Maybe you may want to measure 10 individual self-esteem score, for example. The outcome or dependent variable. Don't forget the outcome, which is this, or dependent variable, which is this. What I was talking about the numeric variable. We have I've said that several times. I'm repeating again. The independent variable are the factor. This one. That is an independent variable. All right. On 3 time points during a specific diet to determine whether their self-esteem improved. All right. So that's what we are looking at now. Okay. So what are the assumptions? Dependent samples must be dependent, which we have explained before. Right. Normality, the same thing is repeated here. Data should be approximated, normally distributed, and have metric scale level. This assumption is especially important when the sample size is small. I've explained that before. Homogeneity of variance is very important. The variance in each group should be equal. You can do that with Levington test. This one can be checked with Shapiro, and we can also look at the homogeneity of covariance. That is fericity. All right, fericity is dealing with combinations of all different groups. We should be equal. So we saw that using GS the other time. Then no extreme layer must be seen because it can disrupt the test. So the main goal of two-way and repeated measure ANOVA is to evaluate if there is a statistically significant interaction effect between two within subject factors, which are independent variable now, in explaining a continuous outcome variable, which are dependent variable. You understand that language now? So just take note of them. Dependent variable, independent variable. They shouldn't be confusing at this point. All right, I've explained them countless number of times, so it shouldn't be confusing now at this point. Okay, that should be clear. Which one is dependent? Which one is independent? One is continuous outcome variable? Which one is not? Which one is within subject factors? All this one should be very clear at this point. There shouldn't be any confusion now. All right, so take note of that, please. Now we use the self-esteem data set. This summarize self-esteem 2 now. Okay, in the same Datarium package. So it has a self-esteem 2. So we are going to use we have 12 individuals enrolled in the 2 successful short-term trials, which is 4 weeks, control, placebo, and the special diet trial. So we have placebo, which is control. We have special diet trial. So this is a data we want to use now. So each participant perform all 2 trials. Each perform all the 2 trials. In order of the trial, the order of the trial was counterbalanced and sufficient time was allowed between trials to allow any effect of previous trial to have dissipated. So now this is what I'm trying to say the other time, that it's always time dependent. Don't forget that. So the self-esteem score was recorded at 3 time points. Okay, this is more than 2 now. 3 time points. At the beginning, we have T1, midway, we have T2, at the end, we have T3 of trials. That's what we have in the past one, which we did in our last lecture on that one we are over. But this time around, we're having diet included. Then we only have 3 time points, right? We don't have the diet included, which is a control and control. The treatment included, which is control and placebo. All right. Now, the question is to investigate if this short-term diet treatment can induce a significant increase of self-esteem score over time. In other terms, we wish to know if there is significant interaction between diet and time on the self-esteem score. Simple. Don't forget, the other time we have a time and self-esteem score. That's what we have the other time. We saw the effect of time on the self-esteem score. All right. Only for one we are ANOVA. Now we are including this one now, diet. Okay. So this is treatment now. Time, diet and time, or I could have said treatment and time on self-esteem score. All right, so that will be the normal language. Okay, so now the two-way ANOVA, the two repeated measure can now be performed in order to determine whether there is a significant interaction between diet and time on self-esteem. So that's what I just repeated here now. Okay, I just repeated again now. So I don't need to repeat it anymore. So that should be clear enough. All right. Okay, so let's now load the library now and load the self-esteem 2. We can glimpse it and see the result. Let's glimpse it. It comes with the way the format came. So we have a ID of individual. All right, 12 people, 1 to 12, then 1 to 12 again. All right, we have 24 column 5. So we have ID, we have a treatment, factor variable. You have T1, T2, T3. All right. So this is for different time 1, time 2, time 3, and we have the treatment for each of them. Okay. Can have a control, okay, and diet. So or placebo rather. So here we can see it. This is how it comes in this structure how it usually come, right? So we can combine it together with what we used to do, so they can have a ID treatment and score. All right, rather and time then score. Right, you should have to have ID treatment, time, and score. But this T1, T2 is a time actually, which is a different kind of different categorical variable here. So this one is one categorical variable now, this three. So we can just say T1, T2, T3 in one group, all right? Then score in one group. That's all. So we are going to do that very soon. But before that, let's run this and look at it in wide form. All right. So we have a ID treatment. Okay, could be diet, could be control. Then we have T1, T2, T3. You can see it now. So now let's now go and combine together now and make it this T1, T2, T3, make it a one group and the score. Let's separate the score, right? So that we can now have our treatment as a group, our time as a group, then our score as our numeric variable. So let's go and do that now. We are going to use our self-esteem tool as usual. We're going to run our library here called R statistics. Then we pass in our self-esteem to we see time t value score t1 t2 t3. So we run this line of code now. So we have combined them together now, right? So that as usual, as we have done before. So the same thing we did here. So now here we just glimpse and see the what you have done so far. Let's glimpse and see. Now we now have a ID, we have treatment, we have time, we have score. Can you understand now? It's very simple now. It's very straightforward. Okay, very very simple. So it shouldn't be confusing now. So our ID is just individual identity to represent them, so that because the same person is measured first time, same person is measured second time, same person is measured the third time. All right, so that's why identity is very important. So that there will not be any mix-ups. So you are trying to measure a specimen like maybe a rat or whatever. You have to label them. Okay, you have to label them because you can't identify them. You must put a label on them. Label 1, label 2, label 3, label 4, so that when you do the measurement, you can be able to account for it later because there might be some mixed up along the line. So let's if you view, let's say view 30 for example now. Okay, that one is not. Let's view it in form of let's view it here. So let's see here we have a treatment, we have time, we have score. All right, so you can see when you scroll down, this was the first set 1 to 12. Okay, first person, second person again 1 to 12. You can see the third person again 1 to 12 again. You can see. So you can see now. So that is how they are. So that's how they use results. So now you can visualize now by a box plot and see. So we pass our self-esteem 2 here as usual. Our time is x-axis, our score is y-axis. Now we now fill by treatment now. All right. Yes, fill by treatment. So when we run this now I remove this one because I want to see this time around it is necessary now to now see the legend. Okay, because you need legend now because now we are dealing with what additional. I think I say okay, the time is passed again. That's no problem. I will have seen by time, but this time around I'm seeing by I'm looking at treatment to differentiate. All right, so let's run this now. You can see now we have a score here, we have time here, right? So we have treatment. So this color is for treatment. Why the one for diet? Sorry, control and diet. Control, diet, control, diet. So these are treatment now. So this is time in time 1, time 2, time 3. You can see now it's very simple and straightforward. All right, so you just want to see the result. How it look like. Right? And looking at this one, they're not the same. Even though this one look the same here, okay, line, but this one is not the same, right? And this one are different in the different time. The control are different in different time, right? And the diet is also different, but in diet 2 and diet 1 and diet 2 look very similar in their mean. in their mean, in their median. Okay, they look very similar. Okay, but I think even not too far from also diet 3, not too far. Right. So I think we can also use our we can plot the mean and division for that. So let's do that. Let's just see. But now we are using two group now, treatment and time. This time around, we are passing our get statistic now to score. We have found the mean and the deviation of there. So you can use also do the same thing using our usual second method. So if you want, so that's one important here now. So let's look at it. We have control, we have treatment, control and diet, we have time, we have variable, we have our number is 12. So 12 individual, that was the mean, 12 individual. Now we have mean, okay. So what I'm saying, in the mean, you have some closely related mean. We have 87.6, 87.8, 87.7. They're not too far. So this is what I'm saying. This one, this one, this one. All right. That's for diet now. Okay. Look at it. For diet, I just told you now. I've already seen that in the graphic, in the plot here. Me are looking at it, observing it graphically. So you can see the data here. 6, 8, 7. Not too far, but not exactly the same. All right, not exactly the same, but they are not too far from each other. Right, so if you zoom it out, maybe you can see it more clearly. Okay, zoom it out. Look at it, the line here, the line here, the line here. So this line, this one below the line, this one on the line, this one's above the line. So that's the purpose of that line. I can call off make the background even whiter so that you can see clearly. Okay, never mind. So let's check the assumptions now. All right, we pass our self-esteem as usual. So this time around we have two groups now, group by treatment and time. Okay, before it was just time because we have only one group. Now we have two groups now. We want to look at the outliers. So let's check. So there is no outliers. Even from here, from this table, from this plot, no outlier at all here. Can you see that? So same thing applicable here. No outlier at all. Not even extreme. No at all. So that passed already. So we can move on to the second assumption. We can now check the normality assumption now. All right. We run the same test here. We pass in our group by treatment and time. So we run here. So we are looking at a result here. So our p-value is this one is only this that it seems to be lower than 0.05. Others are not. So just stop our analysis. We continue. So the self-esteem score was normally distributed at each time point, except for control. This one at T1 score, control at T1 score at T1 time, as assessed by Shapiro test. So that does not stop our test, so we continue. So let's continue and run our analysis. We are about to compute 2 ANOVA now. The same way we did for 1, the same way we do for 2, so there's not much difference. All right, only difference is that we now use the within our factor variable, and within factor variable here now, we now pass 2 here using factor method concatenation here. We concatenate the 2 together. Before it was only 1, so we don't need to put C here. But now within it becomes 2, we pass it. That's the only difference. Our dependent variable is the same score here. Don't forget, our data is now self-esteem 2, not 1, not previous one. So our ID still remain our ID. So you can see that it's very straightforward and simple. So when you run this now, for example, you have your now you can now have ANOVA result. Check now. You see now. So we have treatment, significant, p-value, significant, test time significant, and the interaction between time and the treatment and time so significant. You can see that. So our GS, we don't look at our GS, that's felicity now. Okay, this one is correct because 0.05 one is 0.06 approximately. All right, so this one is more than 0.05. Okay, so this one is 0.05 approximately, which is also more than 0.05. Okay, and this is 0.05, which is more than it's not less than 0.05. Okay, 0.05 is just equal to 0.05 straight. All right, so it just passed the test for sphericity now. Okay, so it passed the test. So the self-esteem score was statistically significantly different at the different time points during the treatment. Yeah. Okay, based on our result now, all right, there is a statistically different two-way interactions between treatment and time. Okay, treatment and time, they are significant now, all right. So which is very, so we can also do post hoc test, okay, to see between this interaction which one, because we saw that they are significant in type 3 test. So which one of them is actually contributing? You are not even running the effect, okay? You are not trying to look at the effect. Yeah, so but just leave the effect alone, right? But you can look at which one uh, is contributing to the this thing. So a significant two-way interaction indicates that let's see if you can just run it, okay? It indicates that the impact that one factor, e.g., treatment, has on the outcome variable, e.g., self-esteem score, depends on the level of the other factor, e.g., time, okay, and vice versa. So that's what the pairwise is what is telling us. So we can run multiple pairwise comparison to determine which groups are different now. Okay, we know that they are different now because they are significant. So which groups are different in pair? So you can run this. So don't forget group by time, pairwise test. We are not trying to combine the two together. You can do it one by one. Later you can supply treatments here. All right. So pairwise test, score, treatment, pair. If the pair equal to true, can use covariant adjustment or other adjustment p-value if you want to use. So we run this. So based on the t what we have, okay, there's something missing here. So let me just run again. So we have our normal p-value is this, right? For the 0.5, 0.02. This one is significant. This one is significant. Only this and this, but this one is not significant. Both at p, at a normal p and adjusted p, not significant. T1 to score. So if you can change it, maybe the treatment here also. Yes, if I go by treatment as well, you can do the same. If I say treatment, for example, I can run the same test. Okay, that's a mistake, that's an error there. Right, so all right, so what are we saying? We are the pairwise comparison showed that the mean self-esteem score was significant between control and diet group at time at T2 and T3, right? But not at T1, right? So we could report this as follows. We can say that a two-way repeated ANOVA measure was performed to evaluate the effect of different diet treatments over time on self-esteem score. Now, there was a statistically significant interaction between treatment and time on self-esteem score at this particular time, right? So pairwise comparison using PRT test showed that the mean self score was significantly different between control and diet trial at time point T2 and T3, but not at point T1. So that's just our summary and conclusion. So, so this is just a very simple way to handle this. So you can do much more than this. Okay, do much. Don't mind this error. Okay, I'm just passing the wrong argument into the group by score. So it's not supposed to be like that. So pardon me for that. So let's just understand that it is very simple and it's not complicated at all. So you can pass your data run and see the effect as you deem fit. So thank you so much for listening. If you have not subscribed yet, you can do so. And to see more of the videos as they're being posted, I will see you in the next class. Thank you.